morning, one and all. Subject name compiler design. In the previous videos, we discussed about the topics consists of construction of parse table. Now, the entries of the parse table, and then today handle pruning. What is meant by handle pruning, and how to implement this tag for in case of shift reduce parsing mechanism, and also what are the various conflicts that can be developed during shift reduce parsing. So first the grammar which is to be considered for the parse table, predictive parse table construction. See, this is the first production rule. E derives T dash. Second production, E dash derives plus T dash epsilon. Third one, T derives Ft dash. Fourth one, T dash derives star Ft dash epsilon. T dash derives epsilon also. And then fifth, F derives left parenthesis, E right parenthesis, and also one more F derives I identifier ID. This productions list we have seen in the previous example with the grammar, and we eliminated the left recursion and all the possibilities, left factoring, ambiguity, and then the precedence of this corresponding grammar. Now, what are the non-terminals that are available in this grammar? Generally, we have identified the non-terminals capital E dash T, T dash F. So, we know that non-terminal. Now, we have to compute the first, and also we have to compute follow. These computations already we computed in the previous session videos with the corresponding grammar. And the results are to be obtained like this. So, first computation, first of E, we got left parenthesis comma ID, and first of E dash, what we got plus symbol and then epsilon, and first of T, what we got left parenthesis ID, and first of T dash, what we got star and epsilon, first of F, what we got left parenthesis ID. So we are getting these results for applying the computation of first. And whenever we apply the computation of follow of E, we got the result left parenthesis, right parenthesis, dollar symbol. In the previous video, we discussed about this concept, this example of given grammar, and we have completed. The same results we are noting down here. And also we computed follow of E dash. What we get the result? Right parenthesis comma dollar. And the follow of T. What we got the result, that is plus right parenthesis dollar symbol. And the follow of T dash. What we get the result here? Plus right parenthesis dollar symbol. And last one, follow of F. What we got the result? Plus star right parenthesis dollar. So we are going to list out all the non-terminals. So we are going to construct a table which contains rows and columns, where all the rows are to be written with the corresponding non-terminals and terminals. Here, what are the non-terminals here? We described capital E, E dash, T, T dash, F. So these are the non-terminals. What are the terminals in this given grammar? So what are the terminals here? Plus, star, identifier, left parenthesis, right parenthesis, and parenthesis, and these are the non-terminals which are to be available. ID plus star, left parenthesis, right parenthesis, and we have to include dollar. So These are the commutations for to be written. What is called as rows and so non-terminals, terminals across the rows and across the columns. We know that the commutations for the corresponding first of E. What is first of E? So we know that what is first of E here? Left parenthesis identifier. So across the column we have to identify where the across the row, that is identifier. So that rule is to be written, and identify where left parenthesis available, because the two symbols, so left parenthesis are also E dash T dash. So this column row corresponding is to be filled properly. Whereas the second row, if you consider, that is E dash, the non-terminal. So E dash computation first of E dash, what is the result? Plus and epsilon. So here, what is the symbol plus? The corresponding E dash computation is E dash dash plus T dash. Whereas epsilon, if you consider, that is, whereas that is for epsilon, F that is, what is E dash here? Plus epsilon. So here you observe that whenever epsilon appears, then we have to choose the computation of follow of the corresponding terminal. So what is the follow of the C dash? Right parenthesis and dollar. So we have to write the right parenthesis dollar for epsilon. So what is epsilon here? That is E dash derives epsilon. So that is to be written carefully. Whereas if you come to the third one, T, it contains left parenthesis ID. So left parenthesis, we have to write that T derives Ft dash and this identifier clearly. And then next computation is variable, that is T dash, where T dash contains star epsilon. So we have to include the computation, this rule T dash derives star Ft dash in case of star, whereas epsilon, that is to be considered as the follow of the computation, where the follow of the computation for this T dash is to be considered as plus right parenthesis dollar. So that is the plus, but here the production is T dash derives epsilon and the right parenthesis dollar. We have to write the three boxes with the corresponding, and then the last column, last row of the corresponding entry, that is computation for first of F, which is to be considered as that is left parenthesis and identifier. Here identifier is the written with the computation F derives ID, whereas left parenthesis F derives. So here left parenthesis and then identifier. So left parenthesis is this one, left parenthesis is capital by capital, left parenthesis capital E, F derives, and left derives ID. So after writing all the entries, we have to verify the production rules which contains the entries is to be single or more than one. Is to be verified with the corresponding entries. This is called as parse table construction, predictive parse table construction, where we have eliminated all the types of unreachability, left recursion, left factoring, and various things which are to be avoided, and then grammar is free from all the activities. That is, in the previous video we discussed about all the 5 points, and then we have computed first and follow, and then we reach to the construction of this parsing table. In this parsing table, where the rows and columns are to be written with the corresponding entries. What is LL1 grammar? Here the LL1 grammar stands for 2L. First L is to be considered as left to right computation. The computation is left to right to be processed while taking the input, that is scanning the things from the left to right. Whereas another L, second L, that is first L, second L, which is to be considered as leftmost derivation. Leftmost derivation. Left to right, leftmost derivation. And the number 1 within the bracket, LL1, this 1 stands for input to be supplied to the grammar. Every time we are taking some input and then process that input to further making the decisions. So how many, every time so many symbols may appear from that content, so that we are going to move forward ahead to display the results. So in order to take that number of symbols, how many depends on that one grammar. So here LL1 grammar 1 specifies that each and every time we have to consider one symbol. After processing that symbol, next symbol to be taken as one more symbol. After that, next symbol, like that. The input is to be processed with the corresponding only one input symbol. And how can you say that the grammar is said to be an LL1 grammar or not? A grammar is said to be LL1 grammar or not? How can you verify whether the given grammar? So that is to be considered, that is to be now we have to take an example of a given grammar, whether it is following LL1 grammar or not. So here in this example, some set of productions are given and we have computed the first and follow is same as this grammar, previous example, predictive parsing. That's why the computations are also we know, and also we have constructed the parse table with the previous notations. That is up to that we know. So while entering the computations in the parse table with the production rules, and we discussed about what is the entry here. One entry here for each cell, identify the corresponding rules, how many are there. So for example, some of them are blank entries. These are all error states. These are called as error states, and the remaining are filled with some rules. The rules may be single or more in some cases. So here in this example, all the rules are single entries are defined. So we can say that the grammar is LL1 grammar. If any entry which contains more than one multiply defined entries, then we can say that the grammar is not an LL1. So here we are considering with differentiating for this LL1 or not. Previous example, it is LL1 grammar. We have to differentiate. We have taken another example which is to be considered as a different notation where we have constructed the all the eliminations, ambiguity, and after that grammar is free from all the things, and then computed first and follow, and then we have listed out that entries. While entering, we got one production here also one, but if you observe, there are two productions, here one, here one. So here in this cell contains more than one rule. So set operation may be contain more than, but here there is only one. In this entry, only one. Here also only one. Here also only one. But any entry after computation, performing the computations, after noting down any possibility of appearance of the more than one action, the production form, any of the non-terminals across the rows and columns, then we say that it is a more than one production, hence it is not LL1 grammar. Hence, it is not an LL1 grammar. So in that way we can verify, and the process is same up to the computation of first and follow. After performing the computations first and follow, finally, based on the parse table entries, we can verify whether it is LL1 grammar or not. And what is meant by handle and handle pruning? So handle is nothing but it is a substring which is matched for the corresponding body of the production, where the reduction is to be represented with the reverse of rightmost derivation. That means whenever the corresponding match available for that string, that means substring, we are going to substitute in the that production. So wherever that match appears, then we have to replace that with the substring. So that's can be possible some in the reverse of right direction. So that is called as handle. In this example, first one production is given taken, that is S derives small a, capital B. Another two productions, capital A, B, C, capital A derives small b, and capital B derives small d. So here, what is the string that is to be developed? Here, for example, you have taken A, double B, C, D, E. It is the string to be developed. So in this string, applied, what is the substitution of the substitution of the substring? What can I substitute? So maybe we can substitute handle maybe B. So small b, we can apply it. So that's why here right hand side, small b, handle we have to consider is small b. So that is to be replaced with what is small b? Capital A derives small b in this one. So this is one production, and second one is capital A, B, C, and another one is small b and then D. So out of this, we have considered the production that is handle, which is substituted small b with capital A. So what is we have that is D. So what is handle here? Handle here. What is the handle here? So what is the substring that is substituted? That is small b. And in another process, any substituted process that is there, here matching the corresponding body of the production. That means what is the substring which you have identified from the given string? What is the substring that you have identified from the given substring, and then that is match of the body of the production. What is the body here? Body head, production contains head and body. Here head is, if you consider capital A derives capital A, B, C. Here body of the production is capital A, small b, small c. So which is exactly matching the given that substring matching the production. So that's why here we are going to replace this as this capital A. Then we are getting what is D. And then we are, that is here handle is nothing but small a, b, c. Whereas another substring that matches exactly the given body of the production, which is identified as capital B derived small d. Then capital A, capital B. What is the handle here? Handle is, so we are going to get different types of handles for each of the reduction of the production substring, and then we are going to be getting the result for that corresponding. So each and every time it is substring that finally we got the result small, that is here capital B and small. So if any match identified in this one, then that is reached to the corresponding. So here one more handle we can get. Here S derives capital A, capital B, small a. Now what is the handle here? Small a, capital B, capital E. What we are getting? Yes. So S is the replacement. That is the final substitute. So S derives small a, capital B, small e. Then what we are getting? Handle is and the handle is small a, capital B, capital E, and yes, finally we got this. So in this way, it is a simple one. Only we have to verify the given string or substring in the given substring which is to be available in the given string match, that is exactly matches the body of the corresponding production. Then the reduction is to be replaced with the represented as rightmost part of the reverse of rightmost derivation. Then it is called as handle. What is meant by handle pruning? If you come to the topic, that is handle pruning, some of the entries which are to be available in the terminals and that is terminals and left hand side non-terminals, which is from the parse tree, it is called as handle pruning. That is entries removing of the children left hand side non-terminal from the parse tree, it is called as handle pruning. And we can also say that a rightmost derivation in the reverse can also obtained by handle pruning. Previously we have seen handle. Now handle pruning, simply we are going to substitute the corresponding production with the left hand side of the non-terminal. Then we can say, for example, here in this id plus id star id is the given one. Then the production that is to be applied, reduced production, that is handle is id and this e derives id. What we are getting? id plus id star id. So various productions may be available. So that production we have to verify. So this is one production, e derives id, e derives e plus e, e derives e star e. So these are the list of productions which are to be available. For this, which of them is to be applied handle and then get reduced to the handle product. So here we know that e derives id. Since e derives id, so we applied e plus id star id. That's why you got the second entry e plus id star id. Where we can also apply one more entry, that is e plus e star id. That means where we applied the same, that is e derives id. What we getting for this one. And in the third case also we applied e derives id. What we are getting? E derives, finally what we get? E derives e plus e star e. That means that is the string by applying this. Then what is e plus e? Because of the production, e derives e plus e. So e star e. So that is the applied one. And here that applied e plus e is nothing but handle. Here two times applied id, e derives id each time, and we got finally e plus e star e. But here in this time we applied e plus e. That's why handle is e plus e. And after applying that one we got e star e. Now handle is e star e. What is the substitution here? E derives e star e. That's why you got finally result is e. So in this way we are going to substitute each of the production in the sequential form, and by applying each time an handle, and we are getting the handle pruning. This is to be considered as an example of handle pruning. Shift reduce parsing is another concept which is nothing but reducing the string to the start symbol of the grammar. That means we are applying the handles pruning, but after applying this one we are getting the string smaller and smaller, and this smaller and smaller finally reduction to a starting symbol of the grammar. That is nothing but shift reduce parser. So what mechanism it is to be implemented by the shift reduce parsing? So one is a stack mechanism is to be implemented, and input is tape is to be used to hold the corresponding string, and it performs two actions. Shift reducing performs two actions. One is shift, another one is reduce. It performs two actions. One is shift, another one is reduce. So in the name itself it is there, shift reduce parsing. One is shift parsing, the two actions. In the shift action, current input symbol in the input string is to be pushed to the stack. And each and every time the reduction, the symbols are to be replaced by the non-terminals. So here reduction applied, replacing non-terminals. You have to replace each and every non-terminal, and the right hand symbol which is applied at the right hand side of the production non-terminal then is to be considered as the left hand side of the production. So we'll see an example how this shift reduce parsing can be applied. Each and every time the non-terminals may appear, and that is to be scanned with the corresponding input symbol, and where this replacement happens by this non-replaced by that the symbols are replaced by non-terminals, rightmost productions, and every non-terminal up to the left hand side of the, that is left hand side of the production. So with the help of an example, we will see that how the shift reduce parsing can be implemented. So here it is considered as the stack implementation of shift reduce parsing. Stack implementation of shift reduce means we are implementing a stack implementation procedure in shift reduce parser. Stack implementation in case of shift reduce parser, it is nothing but stack implementation of shift reduce parsing mechanism. So what is we know that stack content. So stack contains some inputs, some symbols to be maintained inside this one. So that is the first entry to be considered. So in this grammar, we have taken some e dash, e plus e dash, e star, e dash, left parenthesis, e dash, id. And then what is the string to be developed here? Well, input string here. In this example, an input string also to be given to process that one. And we have to apply this stack implementation by that is shift reducer mechanism. So and also we can tell that whether this string is accepted or not. Finally, at the end of the table, we are going to describe that yes, this is the string. How can you say whether the string is accepted by grammar or not? Grammar or not means whenever we applied the reduction of the matching the string and replacement of non-terminal with the corresponding string and finally reach to the start symbol, then we can say that it is grammar accepted. If not received by this star symbol, then we can say that it is not a shift reduce parse. Then here first entry in the table is stack contents, we know, and the second entry is an input. That means what is the input is given by this id, that is to be considered initially. And what is the action? Here action contains shift is one action. There are previous slide we say that there are two actions. One is shift action, another one is reduce action. So shift action means whether you have to move the symbol, non-terminal symbol to the stack side. Reduce means the corresponding substring which matches the corresponding production, then that is to be replaced with that one. So how this one, we will see this in this example. Now initially stack is empty. That means here it is initially empty. Empty means it doesn't contain anything, only dollar symbol. Only the dollar symbol is to be written. Then and the input initially we have to consider what is the input given by the user. So here input is given as, what is the input that is to be given? id1 plus id2 star id3. What is the input that is to be considered? id1 plus id2 star id3. Now, what is the action to be applied? So here we have to decide what is the action, either shift action or reduce action. Since the stack is empty, since the stack is empty, initially we have to apply shift. Why? Because there are no symbols. There are no symbols in the stack, so it is empty. Initially, stack is empty dollar. So empty. We have to consider the dollar symbol only where stack contains. So here we have to apply the shift. What is the shift means? Inside the input string, what are the contents that are available in the left hand side? That is to be shifted. So what is the content that is shifted? That is here only identifier 1. So that's why you have to shift identifier 1. Since we applied shift y, because there are no entries in the symbol table to verify whether the match occurs or not. If any match occurs, we can apply either shift or reduce. But here there are no contents initially, and we kept identifier 1. After that, we have to verify what is the identifier that is to be matched. So instead of numbers, we can consider this identifier 1 or identification to be matched. Here we see that production appeared. So that we can as reduced. We can say that it is reduced. So what we got? E derives capital E, since capital E derives ID. Since capital E derives ID, we are going to apply the reduction process. So reduction means the production. After substituting the production, the string is to be reduced into some other form, and finally that form is reached to the start symbol or not can be verified. So here we reached that is we got an output that is capital E. Then come to the input string, here plus identifier to star. Then there is no applying of reduction. Why? Because the entries in the symbol table and the given productions are E plus E star E, capital E, and identifier. So capital E derives parenthesis E, then there is no use of reduction, applying this reduction. So we have to shift one symbol. What is the symbol we have to shift? Plus. One entry of the from the input each and every time one at a time, not more than one symbol. Only one symbol we have to process the input to the stack content. So here one symbol plus that is to be processed and sent to the stack. Wherever stack contents, that is to be appeared on the top of the string. So that's why we have to kept the plus symbol after the symbol E. So why? Because each and every time already E is available, then we have to place E. Then one more symbol top. Like this, the stack contents are to be inserted properly each and every time. So E plus what we got the result, there is no reduction process from after this entry. So that's why you have to apply one more time a shift operation. So what is the shift operation? We have to use a identifier, that is E plus ID. E plus ID. Once E plus ID is reached, then we have to verify shift or reduce. We have to apply either shift or reduce. Which one we have to apply? Then here, no, verify what is the identifier here. E derives ID. One more. So that's why we applied E derives ID. One more time, E derives ID. So we got this result. Once again, shift operation, E derives, we got E derives ID. Let us see this contents dollar E plus E. Why? Since E derives ID, this is the reduction process. Reduction we applied, reduce the E derives ID. Now what we got? E plus E. Then we have to we see the contents of the input only, another input star. So we process star, and then one more input to be processed, that is shift operation star id. And then here e star reduce e derives id by applying, we got e plus e star e plus e star. Now e plus e, we got e plus, what about e star e? Here we got one more option, that is e and e, and otherwise e plus e star e also you got e only. So finally we reach to the, what is the, then here there are no input in the string, input is empty, there are no further symbols to shift or reduce, and hence finally we got the result capital E, where it is exactly matches the corresponding starting symbol of the given grammar, hence it is accepted, hence the grammar is accepted, hence the grammar is accepted. If it is not reached by the corresponding non-terminal, then the grammar is not accepted. Then the grammar is not accepted. Why? Because each and every time we are going to process the input symbol and we are going to verify any shift or reduction process. Each time we got a shift or reduce, then finally we reach that target. We reach the target. E plus identifier, E plus E is, so first initially we taken the consideration of input symbols, given input, and then verifying whether it is the corresponding substitution matches the list of production or not. If not, then the input is to be considered as one more step, and then we are verifying whether it is matching or not. If not, then further in shift or reduce. So one is stack entry, second one is input, and third one is action. So initially stack is empty, and initially input is what is to be given, that is to be considered id plus id star id, and action shift reduce, and the stack is empty initially, and then each time we are going to pass. So this id plus id star id input is to be considered, and first initially empty stack, and then first input symbol, second input symbol, third, fourth, fifth, like that. Each every time we process and then verify, shift or reduce, apply that shift reduce, and verify that the given grammar is accepted. Given grammar is accepted. So this is called as stack implementation of shift reduce pass. So we are going to find out handle and then applied handle pruning, that is two cases called as shift reduce parsing, which is helpful in case of shift reduce. Two actions. We are going to reduce the string from the input, given input, to the symbol of the grammar, any string of the grammar, and that is to be checked whether it is reached or not, accepted or not, and can be verified and tell that the given grammar is a shift following shift reduce grammar for the given. So here in this example, id plus id star id is the given input string, and it is the, and for the given grammar, it is for the given grammar the string is accepted. For the given grammar, string is accepted. So for this we have constructed one table, where this table contains three columns. First column specifies the stack content, second column given input string, and third column action. First consideration of stack content empty, input string is to be taken. Third one, action shift or reduce. Each and every time we are going to process one input symbol, and this input is to be considered as to take further input, to consider allowing into further input symbol into the stack, verify whether any action is to be applied. So here we verified the corresponding entries. Each and every time shift and reduce, some action is to be considered, and then based on that entries we say that the reach the some symbol, and finally see that this is input is empty. See that there are no more input symbols. No more input symbols. Finally, then we can stop the process. We can stop the process and verify the stack contents, and verify the stack contents of the given of the entries in the table. If it leads to the not terminal, then not non-terminal, which is to be same as the start symbol of the given grammar, hence the accepted. Hence it is accepted. So in this way we are going to implement the stack implementation of shift reduce parse. Then conflicts we are going to see in the next session. All the contents which are available in this textbook, compilers, principles, techniques, and today and now we are going to complete this session. And thank you once again, all of you. We'll come with one more topic with the contents. Thank you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.